this project is to look at a class of chemicals known as endocrine disrupting compounds. And these are predominantly organic synthetic compounds, so they're created by humans. And they get into the environment in a number of different ways. The reason they're called endocrine disrupting compounds is because they disrupt the endocrine behavior of a wide range of organisms. And they do this by mimicking the behavior of natural hormones in these organisms. And there are thousands, literally thousands of these things, and that number is growing every day. And they're very difficult to analyze chemically. One of the main reasons is because they exist in environmental systems at very, very low concentrations, trace concentrations, parts per trillion, which is very low. They can be in water, they can be in sediment. Why we're focusing on estuaries is because estuaries are incredibly important resources for the planet. They're very biodiverse. They serve as a nursery ground for many of the marine organisms that have a great economic value. On top of that, they're areas where people like to live. Roughly 60% of the world's population lives next to an estuary. And so you have this juxtaposition of people and this incredibly fragile, biodiverse ecosystem, estuaries. And into these systems, we're dumping all kinds of things, including endocrine disrupting compounds, many of which we don't even know what they are. So it's an important, from that perspective, we need to start to understand at a much deeper level what happens to these chemicals when they get into these systems. Now, there is quite a bit of work that has been done on the source side, which is how do they get into these systems, and on the receptor side, which is what happens when they're in these organisms. The part that is really kind of mysterious is the fate of these chemicals when they're in the estuary before they show up in the receptors, and that's what we're focusing on at Auburn.
The first part is sample collection. Like we had to get a reasonable quantity of sample from different depth of the environment for better analysis to look for these chemicals elaborately. Second thing, once you bring these samples to the laboratory, how we are going to identify pre-concentration of the sample, how we can determine with the validated analytical methods. So those are the other challenging parts involved in this study.
We would like to study estuaries worldwide. Right now we're focusing on northern Gulf of Mexico, predominantly Mobile Bay, Perdido Bay, and the watersheds that feed these bays. But our goals are to move over to Louisiana and Texas in the northern Gulf. We'd like to go to the East Coast, the Carolinas, Virginia. We'd like to go out to the West Coast, California, Washington State, Oregon. These are all unique types of coastal plain estuaries, and they all have the same problems. But they're different, see? So from an ecosystem level, the organisms that live there are different. The water chemistry is different, but the problem is the same, right? And hopefully someday we can go to other places in the world and look at these things too. So we have very ambitious goals for this program. We'd like to see it go for many years.